Okay, so recording for the start. Yeah, so today what we are going to start off with is introducing IP version 6. Okay, so routing protocol like RIP version 2 and configuration of RIP version 2, concepts of RIP version 2 is what we covered last time in the previous session. But today what we are going to do is we are going to start off with IP version 6. Okay, now we are not going to go into absolute detail of IP version 6, but at least we'll have a basic understanding of IPv6 and what are the features that are available, how to configure basic IPv6 and so on. Okay. So one of the main things about IP version 4 is, okay, IP version 4 में IP address shortage को maintain करने के लिए, manage करने के लिए बहुत सारे mechanisms create किए हुए हैं, जैसे CIDR, that is classless interdomain routing. Okay, now this is nothing but your subnetting which you configure. Okay, one large address space is broken down into smaller subnets, right? So you're manipulating the subnet mask or modifying the subnet mask, and then you are making sure that you are able to utilize all the IP addresses effectively. So that is what you get out of CIDR. But like certain times, what you need to do is you want to break down an address space into smaller and smaller subnets. That is, you break down one large address space into smaller subnets, and then you further break it down into further smaller subnets. That is what is called as variable length subnet mask. Okay, so you're manipulating the subnet mask further and further, and then you're breaking down the address space further. Okay, another option that is available is NAT, network address translation, under which you have the option of static NAT or dynamic NAT or PAT. You know, these were the things that we talked about earlier. Now, for ease of IP addressing on the systems, or for automatic provisioning of IP addressing, we have the DHCP server, that is Dynamic Host Configuration Protocol. Okay, so like a lot of the devices or majority of the devices that are there that are available today are supporting IPv4. But saying that, when it comes to IPv4, they are slowly getting exhausted, especially the public IP addresses. Private IP addresses are free to use, so within a LAN it's not a problem. Like you can use any particular range of private IP address that is available, and accordingly you can work on it. But public IP address is something that is supposed to be unique. You are supposed to purchase the IP address and you are supposed to utilize them. So you'll see that over a period of time the public IP addresses are getting finished, right? So that's the reason we need to have some more techniques or additional techniques to be available so that we can save or conserve on the IP version 4 addresses. Okay, so that's where, when it comes to the problems that are there with regards to those workarounds which you saw in the previous slide, one of the major problem with the workaround of NAT is NAT would break the end-to-end IP model, right? Because what does NAT do? NAT translates the source IP address from private to public, or it translates the source address from one IP to another. So bottom line is, when we are talking about end-to-end connectivity, that is one end of the network to the other end of the network, especially across the internet or across the public network, we normally implement NAT, right? So in that case, the machines are not able to communicate with each other directly because there is NAT. So naturally the IP address gets changed. So you cannot do a direct communication of private to private IP address communication. So in general, it also breaks down the end-to-end network security. Like if you're talking about VPN connectivity and all that, VPN does not work along with NAT, right? So that is one of the applications which is not NAT friendly. Okay. Also, when we are talking about merging of private networks, it is difficult to do so if overlapping IP address ranges are utilized. Like for example, let's say between Nasik and Mumbai, if I want to set up a connectivity, okay. Now in that case, if I'm using a private address of 192.168.0 dot something, and you guys at Nasik also are using 192.168.0.0, then in that case, we cannot have direct communication. We need to make use of NAT, right? So that's the problem with it. Like end-to-end communication or using the actual IP address is not possible when we make use of NAT. So that's where a new technology or a new configuration that is available is IP version 6. Now IP version 4 was 32-bit, divided into 4 different octaves, and that in turn gave us 4 billion IP addresses approximately. But on the other hand, when I talk about IP version 6, it is 128-bit. okay, which are divided into these kind of fields. Okay, there are 8 fields that are available, and each of those 8 fields, okay, is of 16 bit. Like as you can see here, the addressing is based on hexadecimal digits, and one hexadecimal digit corresponds to 4 bits. Okay, so as you can see, in one field we have 4 hexadecimal digits, and that's what makes it 16 bits. Okay, so 16 into 8 is 128 bits. So you get these many number of IP addresses out of IP version 6. Now the best part about IP version 6 is it gives you a large address space, right? I mean, as compared to IP version 4, naturally it will give you a larger address space because it is 128 bits. But on the other hand, the header of IP version 6, which I'll show it to you in a little while, the header of the IP version 6 address is simpler. There are less number of fields, and it can carry a lot more amount of information as compared to IP version 4. By default, it has built-in security features like IPsec, for example, is already built into IP version 6. You do not need to configure IP version 6 IPsec separately. It's already there as part of IP version 6 addressing. And it also provides you transitioning features, good transitioning features like, you know, if you want to have compatibility between IPv4 and IPv6 network, you can easily do that with IP version 6 network. Now talking about the format of IP version 6, as I told you earlier, it is like separated into fields of 16-bit hexadecimal digits, and then each of those fields are separated by a colon. Like as you can see here, 2001, which you see out here, that's the hexadecimal value of 2001, and then that is separated by colon again, and then 0db8 and so on. But then the problem is, you know, every time writing this large number of IP version 6 address becomes difficult. So that's where what you can do is you can compress this particular IP version 6 address. How? Like if you have this kind of a value, 0db8, this can be like, you know, represented as db8. So the leading zeros or the initial 0 values can be ignored, like 0001 can be represented as 1. 0000 can be represented as just 0. Also under that also, if you have multiple fields of 0, like, you know, multiple successive fields of 0 like this one, it can be combined all together and represented as colon colon. So effectively what I'm trying to say is this single IP version 6 address can be represented or compressed down to this kind of a value. So that makes it simpler. Okay. Now, when I talk about addressing types for IP version 6, in IP version 4 we have unicast, multicast and broadcast. But in the case of IP version 6, there is no concept for broadcast. Okay, we have unicast just like IP version 4, which is one-to-one communication. We have multicast, which is one to a group. Okay, as you can see, like from this particular node to this group or these group of machines. Okay, that is what is multicast. But instead of broadcast, which is one to all, we do not have this broadcast in IP version 6. Instead of that, we have something called as Anycast. Now, what is Anycast? Anycast is one to the nearest node. Okay, again let me repeat. When I talk about Anycast, Anycast is one to the nearest node. Now, what is the logic or what is the concept behind it? Anycast is like something similar to what is utilized for accessing the Google DNS servers. Okay, I hope you guys know that Google has its own public DNS servers, 8.8.4.4 and 8.8.8.8. Okay, but one thing you'll notice is like wherever you go, and if you open up the command prompt and if you try to ping the Google DNS servers like 8.8.4.4, you'll notice that the time is very like less. You know, it does not take a huge amount of time to reach that particular DNS server. So I don't mean to say that the Google DNS servers or these IPs are not just located in one single location. They are spread across the globe. But then wherever you are, depending on your location, it will always try to go to the nearest data center and reach this particular address. That's the kind of a thing that they have configured for the Google DNS servers, and that is IP version 4 Anycast. Okay, so that implementation is called IPv4 Unicast. But then the concept is the same, right? You're trying to reach the nearest node, and that's what you get out of Anycast. So in this case also, when I talk about this node, for this node, maybe this one is the nearest one. So that's how it will try to read. So that's what it will try to communicate. Okay. In fact, if you want to read more about the Google DNS server deployment, you can always go to the internet and you can search for, let's say, IPv4 Anycast. Okay, so automatically you will get information about that. You understand? Okay, so remember, Anycast is not just limited to IP version 6. It can also be utilized in IPv4 deployment. And as you can see here, for example, one of the well-known applications for IPv4 Unicast is DNS. So that's the logic behind it. Okay. Now, talking about the IP address scopes and prefixes, like in the case of IP version 4, we have the logic of the subnet mask, which defines how many bits for the network, how many bits for the host. But that's not the case in IP version 6. In the case of IP version 6, we have something called as global unicast address, site-specific unique local unicast address, and then link local unicast address. Now, what does that mean? It means that global is on the internet. Across the internet, if I want to have a unique address, so that's where we have the global unicast address. Okay, so across the internet, if I want to define a IP version 6 address, that is represented as the global unicast address. But based on a geographical location or based on a particular site, like a particular geographical location, if I want to define a unique address, that's where we have the unique local unicast address. And then link local is within a system, like a computer, for example, or a server for that matter, can have multiple network adapters. So within that, if I want to have a link local or a unique local address, that's where I have the link local unicast address. So understood the difference between the three? Global is across the internet, site is across the geographical location, and link local is for a specific network adapter. So talking about that, okay, by default, network ID is the first 64 bits and the last 64 bits is the host ID. Okay, that's the default manner in which IP version 6 addresses are defined. So remember, the first or leftmost 64 bits are the network ID and the rightmost 64 bits are the host ID. So in that case, talking about the IPv6 global unicast address, the one that is used on across the internet, so it is an address which is assigned by INA, that is Internet Assigned Numbering Authority. Okay, so according to that, the first 3 bits of the global unicast address is reserved as 001. Okay, that's the main thing about the global unicast address. So remember, the first 3 bits of the global unicast address is reserved as 001. And like I told you earlier, when it comes to IPv6, every single digit is a hexadecimal digit, and one hexadecimal digit represents 4 bits. So effectively what I'm trying to say is, if the first 3 bits are fixed as 001, the next bit would be 0, if at all I assume that. In that case, it will be represented as 2. Okay, because the hexadecimal digit would be 0, in binary it will be represented as 0010, that effectively represents it as 2. And that's why it is shown as 2000::, that is rest of the fields are all 0 and then /3, that's the prefix information. Okay, so remember, the first 3 bits are fixed at 001, then the next 45 bits are the global routing prefix, that is the global network information. The next 16 bits, okay, becomes the site local address, okay, and then the last 64 bits become the host ID. Okay, so that's the way typically you would define a global unicast address. So for example, we can define it as 2001:/64. That would be a global unicast address. Okay, so just to give you that example again, if I open up my pen here. Okay, it needs .NET Framework 4.7. So I need to go ahead and install that, then only that pen will open up. Okay. let me go ahead and install that. But while that is happening, rather than opening up the pen, I'll use a notepad. Okay, so I'll just download the .NET framework, because unless and until I do not install it, it's not going to work. So as you can see, it's going ahead and downloading and installing .NET Framework 4.7. But meanwhile, just to give you an idea, like I told you, the first 3 bits are reserved as 1, reserved as 001, right? So if at all I consider the 4th bit as 0, so that will be 1 hexadecimal digit, right? So if I consider it in terms of hexadecimal, this corresponds to 2. Okay, the hexadecimal value would be 2. So basically, like if I take an example as 2001, so bottom line is this first digit which you see out here, that is this one, that is this particular part, and then the remaining 45 bits out of that I'm using 1 out here. Understood that part? Then colon, because everything has 0, and then let's say I define it as 25. Okay, so 25 meaning 0025, that's what I'm representing out here. Okay, and then /64, that would be an example of a global unicast address. Understood the logic? Okay, so that would be an example of a global unicast address. Okay, similarly, if I talk about 2111, for example, colon AB D9. Okay, I'm just giving you an example out here. I don't mean to say that this is the only information or this is the only value that you can have. But let's say this is another example of a global unicast address. But most of the times it will be like this. Even if you have something like 3, that also means the same. That also would be a global unicast address, because even in the case of 3 would be represented as 0011. So in that case, still the first 3 bits are fixed at 001. So that would be an example of a global unicast address. Okay. So that's an example of a global unicast address. Now going forward, if I talk about a unique local unicast address, now that's the site local address. Okay, when I talk about that, you have SC00. Okay, then you have the global ID, that's 41 bits, and then okay, so bottom line is this one would be the local IPv6 address, that's the first 7 bits. Then the next until 48 bits, okay, will be the subnet prefix, that is for the subnet. Then until 64 bit will be the link prefix, okay, and ultimately the last 64 bit is called as the interface ID or the host ID. Okay, but now saying that, you know, when I talk about this prefix of FC00 /7, okay, what it really means is the first 7 bits are reserved to be this kind of a value. Now what does that mean? It means that the first 7 bits would be like this. Okay, so basically if I want to represent F as a hexadecimal digit, in terms of binary it is represented as 1111. Clear? Okay, so in that case, if I talk about C, okay, how is C represented? Okay, C basically corresponds to, okay, it will be 1010. That is what is C. Okay, this will be C, because okay, basically C corresponds to the decimal value of 12. Okay, I hope you know this.
Yes.
Yeah. So in terms of 12, decimal value of 12, correspondingly in terms of if I talk about not this way, it will be not 1010, it will be 1100. Okay, that is what is 12. Okay, so that's the representation of hexadecimal C. Okay, so if I talk about FC, 00, it will be correspondingly like this. Okay, it will be 1111, that's the first digit, then 1100, and then 00000000. Okay, so out of that, the first 7 bits, meaning these many bits, will be represented as in this fashion. Make sense now?
Yes.
Okay, so that's the representation of a local prefix. Then you have the global ID, which is the next 41 bits, because 41 plus 7, that's what makes it 48 bits. So that's the global identifier or the globally unique ID. Then you have the subnet ID, that is like a network address or a subnet address for a particular site. And then finally, the last 64 bit will be the host address, also called as the interface ID. Okay, so bottom line is, when I talk about a linked local unicast address, now linked local unicast address is on a particular adapter. Okay, like whenever we talk about any network adapter, if you have IP version 6 enabled, in that case, if you type ipconfig, okay, you'll see every adapter has its own IP version 6 address, right? And as you can see, it starts off with FE80. Okay, so that is what is a linked local unicast address. So when I talk about FE80, the first 10 bits are reserved as this one. Okay, so basically, just to give an idea, the first 10 bits, meaning it will be like this. FE80, okay, will be represented as F is nothing but 1111. Okay, E is represented as now E would be 1110. Okay, that is what is E. Then 8 is 1000 and then 0000. That's the way it is represented. And out of that, the first 10 bits, that is, these are 8 bits and these 2. The first 10 bits are fixed as this one. And that is what is the linked local address. So remember, every network adapter will generate its own linked local address. So out of that, the first 10 bits would be FE80. Okay, and then, okay, out of that, the remaining, whatever that is, like that is 54 bits. The remaining 54 bits would be 0, and the last 64 bits would represent the MAC address of the network adapter. Okay, now again, it is not exactly the full MAC address. It will also include some more values to it, but that is what is called as the interface ID. But remember, the linked local unicast address will always start off with FE80. Make sense? Now, let's talk about multicast addresses. When I talk about multicast addresses, okay, remember the multicast address always starts off with a F, typically FF. Now, there is a small error here. Okay, ideally it's not supposed to be FFFF, it's supposed to be just FF. Okay, so basically it's supposed to be like this. FF. Okay, that's the way it is. Okay, so effectively it is represented as FF00, which will be correspondingly equal to 1111 1111. Okay, and then that's the way it will go about working on that. So remember, the first 8 bits would be fixed as FF. Okay, that's the representation of a multicast address. Understood that part? But after that, the next 8 bits that you have, okay, out of that, the 4 bits would be called as a lifetime. Now, under lifetime, if it is like 4 bits are 0, it will be called as permanent. Permanent meaning a fixed lifetime. Okay, there is no ending or there is no ending value. It's an infinite lifetime. But if it is 1, which means it's a temporary lifetime. Okay, that is what these 4 bits represent. And then the next 4 bits represent the scope. Scope meaning for what purpose is that multicast address being utilized. Like if these 4 bits are 1, meaning it's for a node. Node meaning a particular device. 2 meaning it's for a link. 5 meaning it's for a site. 8 meaning it's for an organization. And E meaning it's for global. So that's the way it is represented. Okay. So typically, if you talk about FF01, okay, so if it is, let's say, FF0 and then 1, meaning it's a permanent node-based multicast address. Make sense?
Yes.
Okay, so it's a permanent node-based multicast address. That is what it represents as FF01. So remember, there is a small typing error here. It's supposed to be FF, not FFFF. It is FF, and then we have the lifetime value and the scope. So depending upon the bits values, it will be either permanent or temporary. That's for the lifetime, and under scope, these are the parameters that you can define. Okay. Now, the next address that we have is the Anycast address. Now, when I talk about Anycast address, again the same thing. We have the prefix, that's the first 64 bits, and then the host ID. But remember, in the case of Anycast address, the host ID is always 0. Okay, there will be a prefix address, but the host address will always be 0. Okay. Now, like we always looked at the last 64 bits or the rightmost 64 bits as the interface ID, right? So how is that interface ID calculated? Now the interface ID is calculated based on EUI 64. Now what is this EUI 64? Endpoint Unique Identifier. That is what is EUI. But this 64-bit address which is generated is based on the MAC address. Now earlier when we talked about MAC address under layer 2, we defined or we understood MAC address as a 48-bit address. Do you remember? MAC address is a 48-bit address. Again, it is hexadecimal, but it's a 12-digit hexadecimal value. So which means it is only 48 bits. But we ideally want the interface ID to be 64 bits. So what they do is they break down this MAC address into two parts. Okay, so as you can see here, 6 digits and 6 digits here. So between those 6 digits, they'll introduce this value of FFFE. Okay, so that means you take any MAC address, break it down into two parts, and in between you add FFFE, and that's what will make it 64 bits, because FF would be 8 bits, FE also would be 8 bits. So basically, you to the 48-bit MAC address, you're adding 16 more bits, and that's what makes it 64 bits. Understood? Okay. But in that case also, okay, like this 7th bit that you see out here. Okay, out of the first 2 digits, the 7th bit, okay, they'll either keep it as 1 or 0. If that 7th bit is 1, it represents universally unique. But if that 7th bit is 0, it means it is locally unique. What does that mean? Universally unique meaning it will be used globally. Okay, but locally unique meaning it will be unique within the computer or within the system. Make sense? Okay, so remember, whenever we talk about a MAC address, that MAC address is converted to a EUI 64 address or a interface ID, and it is done in this particular fashion. Okay, and that's the reason whenever we talk about a linked local address, like which I showed you earlier, you know, this FE80, and then after that they have this particular value. That is nothing but the MAC address of that particular adapter. Understood that part? Okay, like here 5C22 2303 F680 and so on. You know, whatever value you see here, that's nothing but the MAC address. Now, just to give you an example, like here it shows Ethernet 6, right? So let's say I go in for on this particular command prompt, I'll type ipconfig/all. When I do that, it will show me the MAC address also of Ethernet 6. So let's take a look at the MAC address of Ethernet 6. There you go. Ethernet 6. The MAC address of Ethernet 6 is B4 D5 2F C6 685D. Okay, so that is what I have. So I'll just copy this. Okay, so typically if I want to generate a like EUI 64 address, it will be like this. I'll just paste it here. Okay, I've not copied it. So let's say I just press enter, that will copy it, and then I'll paste it here. Okay, and then the hyphens I'm going to represent it with a colon. Okay, in fact, rather than doing that, I'll just put it up in this fashion. Okay, and then what I'll do is I'll separate these two in this fashion. Okay, and then what I'll add is FFFE. You get that? So bottom line is, this is what I'll get, you know, when it comes to the EUI64. Ideally, this is the value that I need to see. But after that also, in this case also, if I want to represent B, how will I represent B? B represents 11. Do you agree? Okay. So 11 would be like this: 1011. Okay. Okay. 4 is represented as 0100. Do you agree? Okay. B is this one, that is 11. Okay. I hope this is 11. No, this is not 11, right? Okay. 8. Yes, it is 11. Okay. So this is 11 and this is 4. And out of that, the 7th bit in this case is 0.
0.
Right? Okay. So what did we see for 0? If we see the 7th bit as 0, which means it is locally unique. Okay. But if it was 1, then it would have been universally unique. Understood the logic now? So remember, EUI64 address will always represent the MAC address. But in our case, if I look at this entry here it does not represent any of these values. Right? It shows something else altogether. Okay? That's because it is an internally generated linked local address, but that's what is generated by my Windows 7 machine, Windows 10 machine. Okay? But ideally, if it is a EUI64 address, it is going to generate the MAC address, or it's going to generate the EUI64 according to this particular logic. Do you understand that? Okay. Now, let's talk about IP address allocation in the case of IP version 6. Whenever we talk about IP address allocation in IP version 6, there are two different types of configuration that is available. Okay, we have stateless auto configuration and stateful auto configuration. The difference is stateless auto configuration is automatic generation of addresses based on the neighbor devices on the network. What do I mean by that? Well, in that case, what it's going to do is, let's say if I want to generate an IP version 6 address for this particular machine, I do not need to configure any IPv6 address on this machine. It will just look out for its neighbor, like it will look out for the IP version 6 address configured on the router. It will look out for the IP version 6 configured on the neighboring devices, and accordingly it will generate an IP version 6 address within that particular range. And that is what is called as stateless auto configuration. Understood that part? Okay. So what it will do is, it will look out for the neighbor, router prefix, default route. I mean, it will look out for all that information, and based on that, it will automatically generate a prefix and a 64-bit interface ID, and that will be the automatically generated stateless auto configuration IP version 6 address. But if you are going to use a DHCP version 6 server, in that case, it is called as stateful auto configuration. Understood that part? Okay, so if you are going to use a DHCP version 6 server, it will be called as stateful. But if you are generating the address automatically, it will be called as stateless. Okay, so that was just a initial section giving an introduction towards IP version 6. The next section is about understanding the IP version 6 operation. Okay, so when I talk about the IP version 6 operation, that is the IP version 4 header. So as you can see, in the case of IP version 4 header, it's a bit complex. Why? Because you have a lot of fields out here, right? You definitely have the source address, destination address, you have the data, okay, you have the options field, padding, header checksum, a lot of different fields which are carried along with the original data. But on the other hand, if I look at IP version 6 header, there are less number of fields out there. Minimal information, that is what it's carrying. And that's what makes it a simple header, which is what we talked about earlier, right? IP version 6 header is quite simpler as compared to IP version 4. Now, saying that, just like we have ICMP protocol for ping that is utilized in IP version 4, we have ICMP version 6 that is utilized in IP version 6. But now, in the case of IP version 6, ICMP is not just utilized for ping. Along with ping, ICMP version 6 also does a lot of other things, like it does diagnostic test, that is the regular ping command, that is echo and echo reply, but along with that it also does router discovery or neighbor discovery. Now this is what is typically utilized for the a stateless auto configuration. Do you remember the IP address that is generated automatically based on the neighbor address or the router address? So that is done using ICMP version 6 messages. So in the case of router discovery, it utilizes router solicitation and router advertisement. But in the case of neighbor discovery, it uses neighbor solicitation and neighbor advertisement. Okay, so though all of those which I'm talking about out here, they are all ICMP version 6 packet types. And based on that, it's going to go ahead and utilize and accordingly generate the addresses. So let's take a look at the example of a neighbor discovery. Now in the case of neighbor discovery, what's going to happen out here is, okay, these routers like router A for example, or the host B for example, or router B for that matter, they are all running IP version 6. IP version 6 is enabled across all of these devices, but let's say on host B there is an IP version 6 address already there. So what this host B is going to do is, it's going to give out its own information, and that information is what is called as neighbor solicitation. That's what is called as neighbor advertising. Okay, now this host was already active. Now let's say if I introduce host A onto the same network and if I enable IP version 6 on host A, this host A is going to go for a neighbor solicitation. Now what is neighbor solicitation? It's going to do a discovery. It's going to take that advertisement value from the neighboring devices and then it's going to generate its own IP version 6 address, and that is what is called as neighbor solicitation. So the neighbor discovery process or the neighbor solicitation process is kind of similar to the ARC which we talked about earlier. What was ARC? ARC was IP to MAC binding, right? So similar kind of a thing is what it's going to do. It's going to take the prefix information which is configured on this host B based on the advertisement that it received, and then it's going to add its own EUI64 address and it's going to generate its own IP version 6 address, and that is what is called as the neighbor discovery process. Understood that part? Okay, so this entire process is what is called as stateless auto configuration. Okay, now to do this stateless auto configuration, it has to use some multicast address. Okay, now when I talk about the multicast address, as we already discussed, the first two hexadecimal digits are FF, the next one is the lifetime, and the last one or the fourth digit that you see out here is the scope. Like as you can see here, it is FF02, meaning what? FF, that is always fixed, the lifetime is 0. Okay, 0 means what? It is permanent. That's what we looked at, right? 1 was temporary, but 0 was permanent. And then 2 was for the host or the link, sorry. Okay, 1 was for the node and 2 was for the link. Okay, like if I go back, okay, like if I talk about multicasting or multicast address, as you can see, 0 is permanent and 2 is for the link, and that is what it shows out there. Make sense? Okay. Okay, so that is what it shows out here. So remaining digits are 0, and then under the interface ID, okay, it will take the lower 24 bits and then it's going to, like, for the first 24 bits or the initial bits that are available, it's going to do some modification on there, and that is what is called as the solicited node multicast address. Okay, so basically this solicited node address is nothing but the multicast address with a link local scope. So what does it do? Okay, it is formed by using this kind of a prefix, and then the rightmost 24 bits of the interface ID is what it utilizes. It will add this particular parameter to it, and that's how it generates the solicited node multicast address of 128 bits. Okay, so just to give you an idea here, like as you can see here, that's the multicast mapping over Ethernet. So as you can see, that's the global unicast address because it starts off with 2, as you can see here, right? So 2001, 0dp8, we have all of this value, but out of all of this, what it's taking up is, it's taking up FF02, okay, that's the prefix value, and then the last 24 bits is what it takes up, and then it adds up, this kind of a value for Ethernet, 3333, and accordingly it will generate the IPv6 solicited node multicast address. Understood that part? So if at all it wants to generate a multicast address across the Ethernet, this is what it does. Make sense now? Okay. So now, talking about stateless auto configuration, which I mentioned earlier, as you can see in this example, a host and the router, they are giving out information, right? But now when I say that, the router advertisement, when I talk about it, is given out by ICMP type 134. Okay? Remember, the ICMP type for router advertisement is 134. Okay? And in that case, the source address would be the router link local address. Link local address is nothing but FE80::, and the MAC address along with FFFE, which we talked about earlier. Do you remember that? EUI64 address. That is like appended to the FE80, and that's how you generate the FE80 or the link local address. So that becomes the source, and the destination becomes FF02::1. That's the multicast address that it makes use of. Make sense? Okay, so FF02 meaning what? FF is fixed, 0 is permanent, and 2 is the link address. Okay, so that is what it utilizes, FF02::1, and along with that it will send out the prefix, lifetime, auto configuration flag, and so on, and that's why it becomes the router advertisement packet. Make sense now? Okay, so the host will pick up this router advertisement packet, it will look at the prefix, it will look at the auto configuration flag, and then accordingly it will generate its own address. Okay, and that is what is called as stateless auto configuration. Make sense now? Okay. Now, so as you can see here, this host, as soon as it becomes active, it will go in for a router solicitation. Router solicitation meaning router discovery. So that is done using the ICMP type 133. So what is done out here? In this case, the source address would be : because by default this host does not have a IPv6 address, right? So it will generate a source address of : and the destination would be FF02, again the same thing, but : 2, wherein it's trying to discover routers on the network. Okay, so based on the discovery message that is sent, or the router solicitation message that is sent, the routers are going to give out a router advertisement like this one, FF02::1. That's what they'll utilize, and accordingly this host will take that info and generate its own address. Make sense now? Clear about that? Okay. So let's take a look at how do you configure stateless auto configuration. Now to configure stateless auto configuration, the command line is on the router interface. You have to go in and type in IPv6 address autoconfig. If you just type IPv6 address autoconfig, it will only take the IPv6 address. But if you also want the default route, in that case you have to go in for IPv6 address autoconfig default, meaning along with the address it will also generate or take up the default route. Make sense? Clear about that? Okay. So what I'm going to do out here is I'll go back into my topology diagram. Okay, now my .NET is installed. Okay, but anyways, I'll go back into my topology diagram, and in my topology diagram, okay, what I'm going to do is, okay, between these routers, I'm going to use some IPv6 address. Okay, so like here, what I'm going to do is, like if you remember, R2 and R7, they are on the same network, right? They are on the same VLAN, basically. Okay, so they are on VLAN 1. Okay, so what I'm going to do out here is, on R2, I'm going to configure this kind of an address, 2002.2222::2. That's what I'm going to assign to this router R2. And then on router R7, I'll go up into this particular Ethernet interface, and I'm going to configure it for stateless auto config. Do you understand that?
Yes.
Okay, so let's go ahead and do that. So let me start off with router R2 first. And on router R2, first of all, let me get on into Ethernet E0/1. Okay, so enable and then I'll type show run interface E0/1. When I do that, as you can see, it already has an IPv6 address out here. Okay, now this may be related to some other config or some other kind of configuration that I might have done before. Okay, but this is a configuration that has been done already out here. So let's see if I have that kind of a configuration out here. Okay, I do not have that mentioned out here, but let me go ahead and configure it accordingly. Okay, so what I'm going to do is, okay, let me type in a show run interface E0/0. No, on E0/0 I do not have that address. So I don't know how that IP addressing came in, but let me go ahead and remove it completely. Do you understand that? Okay. So again, first of all, I'll clear out the IPv6 configuration altogether. Now, when it comes to IPv6 configuration, you know, if you want IPv6 routing and all of that, you have to put in a command that is IPv6 Unicast routing. Okay, so that's one of the command that is configured. Like if I type do show run, okay, this is IPv6 Unicast routing. Now by default this command is not put up, so that's why I'm going to go ahead and remove that. So I'll just leave it at the default. Okay, so no IPv6 Unicast routing. I'll remove that. Then what I'll also do is, okay, I'll go into interface E0/1 and I'll type no IPv6 address. That will go ahead and clear out the IPv6 address. And if I look at do show run interface E0/1, okay, so the entire IPv6 configuration is cleared out on this particular interface. Do you understand that? Okay, so now based on that, let me now go ahead and configure the address according to this example here, 2002:2222:/64. That's the prefix, but I'll configure an address according to that. So I'll type in IPv6 address and then I'll type 2002, okay, :2222, okay, and then ::, I'm going to keep it as 2 and then /64. That's what I'm going to define now. Okay, now it's saying error. It says 2002:2222 : /64 is overlapping with this on loopback 0. So it seems like this router has a loopback interface and that has this particular address to it. Okay, so let me check up on that. So if I'll type do show run interface loopback 0, yeah, I already have an IPv6 address out there. So that was what was creating the problem. Are you getting me now? Okay, so what I'm going to do is, for this particular example, I'll go ahead and add another IPv6 addressing so that we do not have any such issues out here. So there you go. I have some IPv6 addresses already. I'm going to utilize that. Okay, I remembered like I had created some text file, but I had, I think, moved it across. But okay, now in this example, what I'm going to do is, let's say, yeah, between R2 and R1, I'm going to use this one. Understood that part? Okay, or let's say I'll use it here between R2 and R7. Okay, 2021 EEFF : /64. That's the prefix that I'm going to utilize. You understand that? Okay. So for now, what I'll do is, I'm not going to get on into the loopback and do anything out here, but I'll go ahead and configure that addressing. That is 2021 EEFF : /64. That's the prefix that I'm going to utilize. So interface E0/1. Okay, I'll get on into that interface. And now at this point, if I type do show run interface E0/1, so there you go. It has not taken that IPv6 address, right? So let me go ahead and now configure that. So IPv6 address 2021 : okay, and then EEFF. That's what I want. So 2021 : EEFF : 2. That's what I'm going to define. You understand? That's the address that I'm going to define /64. And when I do that and press enter, There you go. It has taken it. Understood? It did not give me an error because this is not overlapping with anybody else. Make sense now? Okay. So this is good, or this has been configured. Okay. And now what I'm going to do next is I'll just save it. Okay. And then I'll get on into router 7. On router 7, enable again, and on router 7, let's say if I type show run interface E0/1. So there, as you can see, there is no IPv6 address at all, right? Nothing has been configured out here. So let me now go ahead and configure an IPv6 address here. So config T, but in here, if I go into interface E0/1, I'm not going to configure the IPv6 address manually. I'm going to type IPv6 address, and then I'm going to type auto config. Understood part? Okay. Now the moment I do that and press enter, okay, so it is going to start communication, and accordingly it's going to generate, or it's supposed to generate, an IPv6 address. Now, once I configure this IPv6 address in this fashion, let's say if I go into router 2 and if I want to see the address configuration, I need not type show run interface. I can always type show IPv6 address. Show IPv6 interface brief. When I do that and press enter, there you go. It clearly shows me that loopback 0 has this interface FE80, but at the same point of time, Ethernet 0/1 has FE80, that's the link local address, but along with that, it also has 2021, which we had configured. Do you understand that? Okay, so it definitely shows the IP addressing out here. But at the same point of time, if I get on into router 7, let's say, and there also, if I type in show IPv6 interface brief, and if I press enter, as you can see, okay, Ethernet 0/1, it shows FE80::AA, that's the link local address, but it has not generated any IPv6 address. Ideally, it was supposed to generate an IPv6 address on its own, right? Okay, meaning, they were supposed to talk to each other. Okay, on Ethernet 0/1, they were supposed to talk to each other, and accordingly, they are supposed to generate an address. But for some odd reason, they are not doing that. Are you getting me now? Okay, they are not generating this particular address. Make sense? Okay, so let me give it a bit of time. So again, let me type in. Yeah, so I have this address, but let me now get back into router 7, and there also I'll run the same command again. So it is not showing the address at all. It is not generating the address at all. Okay, so what I'm going to do next is configure terminal. Okay, and then I'm going to type in IPv6 Unicast routing. I'll enable that also, and then let me type in interface E0/1, and I'll type in that command again, IPv6 address autoconfig. Okay, I'll run this command again, and then I'll type do show IPv6 interface brief. Okay, still it has not taken that address. Ideally, if it was supposed to do it, it would have been doing it quickly, but it did not do that at all. Okay, it's taking a lot of time here. Okay. So for some odd reason, the autoconfig is not working out here. You understand that? Okay, but ideally, we are supposed to have autoconfig working. Understood that part? Clear? Okay. Now, to understand this particular example of autoconfig, what I'm going to do out here is, I'll get on into, let's say, packet tracer, because, packet tracer is the best tool that I can go for, because there I can easily show you this demonstration. Okay, because I think it's something to do with Eve or this particular virtualization platform, wherein it does not do the necessary config like what we need. Okay, but meanwhile, I'll also check up on one more thing. I'll go into switch 6 here, and I'll type in enable and show VLAN brief. I just want to check whether all those interfaces are in the same VLAN. So as you can see, Ethernet 0/1. Okay, so I'm supposed to look at 1/0 and 0/0. So if I look at 1/0 and 0/0, they are supposed to be on the same VLAN. So 0/0 and 1, yeah, 0/0 and 1/0, both of them are belonging to VLAN 1. So it should not be a problem at all. They belong to the same VLAN, so they are supposed to talk to each other. But for some reason, the autoconfig is not working at all. You understand that? Okay. Okay. But now let me go ahead and manually configure the IP and give it a check. So what I'm going to do out here is I'll get on into R7. Okay. I'll put no IPv6 address first of all. That will remove the address, and then IPv6 address, and I'll put 2021:AADD. I think that's what it is. No, sorry, EEFF. That's what it is. So EEFF. Now I'm putting up EEFF in capitals, but as such it's not important. You can put it up in lowercase also. Okay. So ::1 is what I'll put up, /64. Now once I've done that, what I'm going to do next is, if I try to ping, okay, 2021:EEFF::2. Let's say I try to ping that, and it is pinging. So bottom line is, communication is definitely there. There is nothing wrong with that. But for some odd reason, it's not working on that. Autoconfig is not at all working. So let me go into router 2 also, and in the global config mode, I'll put IPv6 Unicast routing. Maybe that might help. You know, I'm just going to do that test here. Again, I'll get back into router 7, and of course, right now I have the IP address. So if I type show IPv6 interface brief, I'll definitely see that address which I manually configured. But again, I'll get back into interface E0/1. I'll put no IPv6 address, and then I'll put IPv6 address autoconfig. Okay, that's what I'm going to define. And then if I put up if I put up show IPv6 interface brief, and there you go, immediately it got it. So bottom line was, you know, I had enabled IPv6 unicast routing on R7, but I did not enable IPv6 unicast routing on R2, and that was the reason autoconfig was not working. Understood the logic here?
Yes.
Okay. So R7, even though I enabled IPv6 unicast routing on R2, if you remember, initially I had gone ahead and disabled IPv6 unicast routing, but the moment I enabled that, it started working. Okay. Now let me tell you how this IPv6 got generated. So 2021:EEFF, it definitely got this information from that particular remote router. But then this value, if you look at it, A8, BB, CC, FF, and do you see this FFFE? It is something that is introduced into or between this particular MAC address. So this value that you see here, that is the EUI64 address. So what I'm going to do is, I'm going to type show interface E0/1. When I do that, that is the MAC address. So I'll copy this MAC address, go into Notepad, and what I'm going to do is, I'll paste this MAC address here. So basically, let's follow the logic that we talked about earlier. So I'll break it down into 6 digits each, and between those 6 digits, I'm going to add FFFE. You understand that? Okay. And accordingly, if I try to like put it up or separate it into colons, it will be like this. Okay. And out of that also, the 7th bit, when I talk about it, okay, that is here. You know, I can either keep it as 1, that will be universally unique, and 0 would be locally unique. So that's the kind of change that I can do. But right now, you know, that's the EUI64 address that I've calculated. Let's compare it with that of R7. So if I type show IPv6 interface brief, so as you can see, it is not showing AABB. Instead of that, it is showing A8 and then BB. Okay, meaning what they did was, like according to this one, if I look at the 7th bit, so A, how do you represent A? A is nothing but 10. Do you agree?
10.
So 10 is represented as 1010. Right? Okay. Similarly, 1010. So bottom line is, out of that, the 7th bit is here. Clear? Okay. So this is supposed to be 1 ideally, but what they did was they made it 0. This part, they made it locally unique. Okay. And because of that, now this digit becomes 8. Because this is 8, right? So that's the reason it became A8BB CC FFFE 007010. So that's the logic out there. Make sense now? Clear? Okay. Now at this point, on R7, if I type show IPv6 route, as you can see, there is no direct route or default route or nothing of the sort. The only route that it shows is NDP, that is Neighbor Discovery Protocol, and accordingly it generated this particular address. Do you understand that?
Yes.
Okay. But the next thing that I'm going to do is I'll type config t interface E0/1. Again, I'll type no IPv6 address, and then I'll type IPv6 address autoconfig, and then I'll put default. Okay, so basically I added this keyword of default. So again, because of that, it's going to generate an IPv6 address for sure. There you go, just like before. But along with that, if I type show IPv6 route, I should also see a default route. You see this? : meaning all zeros /0. That's why I define a default route, right? Network is also 0, subnet mask is also 0, and that's what they are representing in IPv6. In IPv6, default is represented in this fashion: : /0, and then it's represented via FE80, A8, and via Ethernet 0/1, meaning it points out to that particular other remote router. Understood the logic now? Clear about this?
Yes.
Okay. So this FE80 which you see here is nothing but the address of that local address or link local address of R2. Like if I go into R2 and if I type show IPv6 interface brief, okay, if you compare this with this one, you see this value here and this value, they are both the same. You see this FE80 AABB CCFF FE002010. So remember, routing is all based on the link local address. Understood part? So this configuration which we talked about right now is the stateless auto configuration. Very clear on this part? Any doubts or questions on this one?
No, neither.
Okay, good. Okay. So that was this particular section here. So remember, IPv6 address autoconfig will only generate the address, but if you include the default keyword, it'll go ahead and add a default router. Okay. So that was that section. This is what we covered right now, which I explained to you right now. But I think that should be it for today. Okay. But tomorrow, what we are going to do is we are going to start off with IPv6 static routing.
Okay.
Okay. So I'll just